Hello everyone and welcome to my channel. Today I'm going to show you how forward deployed engineer designs and delivers a real AI application from scratch. This isn't just a coding project. We will think like engineers working with a customer. We'll gather requirements, design the architecture, choose AWS services, build an application, and automate deployments with CI/CD, and finally deploy everything into production on AWS. Let's begin exactly where every real project starts with the customers. So the first slide is customer requirements. Before writing any code, we need to understand what our customer actually wants. Our customer is a Fresh Mart and an online shopping company. They already have an online store, but they have one major problem. The customer support team receives the same questions over and over, right? So, now, for example, the questions will be sound like what product do you sell? How much does this product cost? What is your return policy? How long does shipping take? What payment method do you accept? Instead of hiring more support agents, they want an AI assistant that can answer these questions automatically. As a forward deployed engineer, my first responsibility is not coding. My first responsibility is understanding the business problem. Let me show you the high level architecture for you here. Um, Now that we understand the problem, what the business problem, what the customer wants, we need to create the high level architecture, yeah? So we create the solution. The customer opens the website using a browser. Every request first goes to the application load balancer. Application load balancer acts like a traffic controller. Depending on the request, it decides which service should process it. If the customer is simply viewing the product, the request goes to the front end. You see in the image, right? If business logic is required, the request goes to the backend API. If the customer asks the AI assistant a question, the backend communicates with the AI service. The AI service searches our knowledge base stores in Qdrant and then sends the relevant information Claude, which generates a natural language response. This is a high-level architecture. Now let's go to AWS infrastructure, what we're gonna create in AWS. Uh, it means from the logical architecture, let's go create to cloud architecture. Everything is deployed inside of AWS. Users connect through the internet. Traffic first reaches the application load balancer. Behind the load balancer, we run three independent services inside Amazon ECS Fargate. One service hosts the React frontend. One service hosts the backend API. One service hosts the AI service built with FastAPI. Each service runs independently, which makes the system scalable and fault tolerant. Next slide is a CI/CD pipeline. In modern software engineering, we never deploy applications manually. Instead, we automate deployments. Every developer pushes code to GitHub. GitHub Actions automatically starts the CI/CD pipeline. The pipeline builds Docker images. Those images are pushed into Amazon ECR. Amazon ECS then pulls the latest images and deploys them automatically. This gives us consistent deployments and reduce human errors. I want to move forward and show the next slide, the request flow. How the request flow goes. A customer opens a website. The request reaches application load balancer. The load balancer forwards it to the front end. Suppose the customer asks, what is the price of apple juice? The front end sends the request to the backend. The backend forwards the request to the AI service. The AI service searches Qdrant for a relevant document. Those documents are included in the prompt sent to Claude. Claude generates the answer and the response travels back through the same path to the customer's browser. This is a container architecture. Instead of putting everything into one application, we separate the system into multiple containers. The frontend has its own container, backend has its own container, and the AI service has its own container. Each container can be updated independently without affecting others. This is one of the key principles of microservices architecture. Let me demonstrate now network, how it will look the network. The application load balancer routes a request based on the URL path. If the request is simply the root path, it goes to the front end. If the path begins with API, it is forwarded to the backend API. If the path begins with a chat, it is forwarded to the AI services. This approach allows multiple services to share a single public endpoint while keeping each service independent. Let me introduce with the RAG. This is where AI becomes intelligent. Suppose a customer asks, what is a return policy? We don't send that question directly to Claude. Instead, the AI service first searches our vector database, Qdrant. Qdrant finds the most relevant company documents. Only those relevant documents are sent to Claude along with the user's question. This technique is called Retrieval-Augmented Generation, or RAG. Because Claude receives the company's actual information. It generates accurate answers instead of guessing. At this point, we've completed what every real engineering team does before implementation. We've understood the customer's business needs, designed the architecture, selected AWS services, planned our deployment strategy, and defined how the AI will work. Now we are ready to build the system. Before developers start writing code, we need to organize the project. We need to decide how many services we will have, how the repository will be organized, which team owns each services, which technologies each team will use, how the teams communicate. These decisions affect every phase of the project. Let's, for a short time, come back to the customer requirements. Can one developer build this as a single application? No. In the enterprise environment, we split the application into multiple services. Because of that, we have now, I want to show you the two architecture. One is a monolith architecture and another is a microservice architecture. Imagine 30 developers working on one huge project. If everyone modifies the same application, they constantly overwrite each other's work. Deployment becomes risky. One bug can crash the whole system. That's why large companies split application into microservices. Let's move to the team organizations. Uh, the team organization will be the project manager, forward deployed engineer, front-end team, back-end team, AI team, DevOps team, and the QA team. Also, I will, the easiness of the lab was useful for you. Also, the interview, I wrote each team's responsibility. Let's read, right? For the front-end team, they will responsible for React, UI, CSS, product pages, and shopping cart. The backend team responsible for the REST API, business logic, authentication, and orders. AI team responsible for FastAPI, Claude, Qdrant, embeddings, and prompt engineering. And DevOps team, finally, we are coming here. We're responsible for the GitHub, Docker, CI/CD, ECS, ECR, and application load balancer. And finally, the testing team, the QA team, testing, regressions, API testing, and performance. Although we are building this project alone, we'll organize it exactly like a real enterprise team. We already gathered customers' requirements and designed the architecture. And now we will move to the code itself, yeah? And I already prepared it so we can focus on understanding how an enterprise application works rather than the spending time to creating folders. The Enterprise AI Shopping Assistant is a folder. This repository contains the complete enterprise application, and every folder has a different responsibility. Front end, let's start from the front end. The front end, the customer-facing application built with the React. This is what users see in the browser. The SRC, the source folders. Source folders here contains React source code, and the public is a static file such as images and icons and package.json projects, dependencies and commands, and the Docker file is the packages the frontend into the container. If we talk about the backend has a responsibility for business logic. It receives a request from the frontend, processes them, and returns data. Main files here, the server.js, Docker files, and the package.json. And last one is AI service. The AI service is completely independent from the backend, and it communicates with the Claude and our vector database. Is a meme.py folder app, and the requirement.txt and Docker file. Mean.py starts the FastAPI server. App contains the AI logic, and requirement.txt lists Python packages, and Docker file the packages the AI service. Beside this, we have also the documents. These documents become the AI knowledge base. The AI searches these files to answer the customer question about products, shipping, payment, returns, and POCs. That means the Claude doesn't know about the company anything, right? So Claude has, in terms to respond to clients, Claude has to understand the document, the company, the store requirements, store policies, and what store exists right now and what a store doesn't have it. Those old documents will be existing in these folders. And finally, we have a Docker folder. Docker Compose allows us to run services together during local development. And the README file that explains how to install, run, and deploy the project. The node modules, if you notice, we have in the backend node modules. I highlight the different node modules. The front end and the backend have node modules folders, both of them, if you pay attention. This contains a third-party libraries downloaded from NPM. We don't edit them; they are managed by automatically. And a Docker file show the here, if you see the three Docker files, they are separate from each other. Each service has its own Docker file because each service becomes its own container. And front-end, back-end, and AI, each of these services will be packaged into its own Docker images and deployed independently. Now you understand how the project is organized, and let me launch the application and start exploring each service in action, beginning with the front end. We gathered customer requirements, designed the architecture, and tested every service locally. Now I'm going to show you how this entire enterprise application works behind the scenes like a real forward deployed engineer. We'll follow customer requests from the browser all the way to Claude AI and back. Imagine you are a customer and you want to ask apple juice. Before we send the request, let's understand what is coming here. Everything starts from the customer. The request doesn't go directly to a server. It first reaches the application load balancer, also called the ALB. This application load balancer runs inside of the AWS. The application load balancer examines every incoming request. If someone opens the website, the application load balancer sends a request to the front end. Let me show the rules, and by the rules we'll explain you more, right? If it shows just if it just shows the opens the website, it will first of all direct it here to the front end. If the request starts with the API, it goes to the backend, here backend. And if it's AI question, the LB sends to AI service. Instead of exposing 3 different public IP addresses, we expose only one endpoint. The load balancer decides where every request should go. Now let's look where those applications are actually running. We have 3 services: front-end, back-end, and the AI services. These are running microservices. Each service runs in its own container. If one service crashes, the other 2 can continue running. This separation makes the application easier to scale, update, and troubleshoot. Every ECS service is created from the task definition. Here we allocate our CPU and Docker images allocated inside of the task definition. And this is the container port the application listen on. Let me show you the container port, network settings. Please, container port. Think of it that task definition as the blueprint that tells ECS exactly how to start the application. Now let me show where we store our images. Our images are stored separately inside of the ECR. So front-end, back-end, and the AI services, they're separated. Before ECS can run a container, it needs a Docker images. These images are stored inside of the ECR registry, and they are separate, as I told already. When we deploy a new reversion, we push a new Docker image here. ECS automatically downloads the latest image from the ECR and starts the container. Let me open the backend API. This is our backend API, and the frontend never reads files or talks directly to databases. Instead, it sends the HTTP request to the backend. The backend performs the business logic and returns product information as a JSON. AI service, this is an AI service built with FastAPI. The backend is responsible for business logic. The AI service is responsible only for the artificial intelligence. keeping AI separate, making the architecture easier to maintain and scale. Claude does not know our company's product, so we give a Claude knowledge. This is a collection stores a vector embedding generated from our business documents. Instead of searching keywords, Qdrant searches semantic meaning. And I want to show the important part of the documents. These are documents that contain our business knowledge. Before customers ask questions, these documents are converted into vector embedding and stored inside Qdrant. Now I want to open the main pie and show you where I embedded the Claude. This is mean Pi is a heart of our AI services. It receives the customer questions, researches. Here I mean that Pi, this is the heart of our AI service. It receives the customer's questions, searches our knowledge base, sends the relevant information to Claude AI, and returns the final answer. We have here a FastAPI. We are using FastAPI because it's a lightweight Python framework for building APIs. This service will receive requests from our backend. The course, next one, is enable the course. Our frontend runs on a different port than our AI service. Course allows the frontend to communicate with the API securely during development. And client is Anthropic. Here we connect to Claude using API keys. The key is stored as an environment variables instead of being hard-coded, which is security best practices. And app.cat, please here. This is the endpoint allows Docker ECS or load balancer to check whether the AI service is healthy and responding. And finally, the chat endpoint. The chat endpoint, the post, which you see here, this is the main endpoint of our AI service. Every customer question arrives here. And inside of the retrieval, this is the most important explanation. This is the line performs retrieval-augmented generation or RAG. We send the customer's questions to Qdrant, which searches our knowledge base and returns the most relevant information. Instead of asking Claude to answer from the memory, we first retrieve company-specific information. We also have a prompt here. I wanted that you pay attention to that. And we build the prompt that will be sent to Claude. And the context. This is the section contains the information retrieved from Qdrant. And questions, the place here, the prompt, please, the context, and the questions lower, this is the customer's origin questions. By combining the retrieved context with the questions, Claude can generate answers based on business document. And response is a client message create. This is the where we send the prompt to Claude. Claude analyzes the context and generates a natural language responses. Notice that Claude never searches our database directly. It only receives the context we provide. And finally, we return the Claude's answer as JSON. The backend receives this response and sends it back to the frontend, where the customer sees the answer. Then let's summarize the complete AI request. Customer, front-end, back-end. AI service Qdrant retrieves relevant document. Prompt is created. Claude generates an answer. AI service returns JSON. Back-end, the front-end, and the customer. This is a core of the retrieval-augmented generation. We don't rely only the language model's general knowledge. We first retrieve the company's own information, then use Claude generate our grounded answer based on that context. Now let's test the application. I'm opening my website running on Amazon ECS behind the application load balancer. As you can see, as you can see, all of our products are displayed from the backend service. Now let's test our AI assistant. I will type here the question. Um, the AI response will be. The AI response with the price of apple juice is $1.99. This answer was not hard-coded. The application searched our company's knowledge base stored inside the Qdrant vector database, retrieved the most relevant document using a retrieval arguments generation, sent the context to the Claude, and Claude generated the final answer. Let me explain you the final complete flow. The, um, the customer types a question in the React front end. The request goes to the application load balancer. The load balancer routes the request to the AI service running inside Amazon ECS. The AI service converts the customer's questions into a vector embedding. That embedding is sent to Qdrant. Qdrant performs similarity searches and returns the most relevant company document. Those documents are combined with the customer's question and sent to Claude. Claude generates a response based only on the retrieved company information. The AI service returns the answer through the application load balancer back to the React application, and finally the customer sees the response. Let's verify everything in running AWS. I'm going to the ECR, and as I demonstrated previously, I have here front-end image, back-end image, AI service, and a Qdrant image. Every service has its own Docker image stored in ECR services. And ECS. Each microservice runs independently inside its own Fargate task. If one service fails, the others continue running. This architecture allows independent deployment and scaling. I have right now the four services, they are separate to each other. And let me show you the load balancer, the final, The application load balancer receives all incoming traffic using a listener. Listener rules, it routes a request based on the URL path. Request to API go to the backend. Request with the chat goes to the AI services. All other requests are routed to the React frontend. This project represents the work of the forward deployed engineer. A forward deployed engineer works directly with the customers to understand business problems and build AI-powered production solution. Instead of building only machine learning models, NFD integrates cloud infrastructure, API vector databases, large language models, and modern application architectures into a complete enterprise solution. In this project, we combined React, Node.js, FastAPI, Claude API, Qdrant Vector Database, Docker, Amazon ECR, Amazon ECS application load balancer, retrieval-augmented generation to create a production-style AI shopping assistant. Although this is a demonstration project, the architecture follows the same design principles used in many enterprise AI applications. Thank you for your watching. If you found this project helpful, please like the video, subscribe the channel, and leave your question in the comments. See you in the next project.